All right, another part that we're going to deal with in section 3.2 that talks about our parent graphs again is how do I write a function, write an equation given a graph. And it's very similar. If you remember when we started looking at graphing these functions, we talked about number one, decide what parent graph we have. So when I look at this function, the graph of it, I recognize it as f of x or y equals x cubed. Okay. So that's why we're going to start. Number one, again, determine your parent graph. Secondly, I'm going to deal with the up, down, left, right piece. Now, if I think about my parent graph for x cubed, we started at a point 0, 0. We had that point at -1, -1. We had that point at 1, 1. And we looked like those pair of parabolas again. Half parabolas, I should say. So what we're doing is, number one, we're starting by moving this point that originally was at my origin over to the right 3, and then we're sliding it up to its new position 5 steps. And so I can put those pieces into my equation right now. Because again, I know that the 3 affects me in the x direction horizontally, so it's going to go inside, and again, the opposite. Don't forget your cube. And the plus 5 moves me up 5, and that's on the outside because it's a vertical. We'll look at another quick example first of the left, right, up, down, and then we'll come back and talk about how do I know if I got a stretch or a shrink involved here. Okay, so again, if I start this one out, number one, I've determined that I'm dealing with a function that is my square root function. Okay. Thinking again, I start my square root function at 0, 0, we go to 1, 1, we go to 4, 2. And there's my parent graph. So all I've done with this function this time is I've slid it down 6 steps. Okay. So when I update here, that's vertical, so it's on the outside. Okay. So I don't believe that piece is going to give us a whole lot of trouble. The piece that does throw us off from time to time now is going to be the stretch and shrink. And if you think about a lot of our parent graphs, okay, we have something at the origin. Okay, we have that for x squared. We have that for the square root of x. We have that for the cube of x. We have that for the cube root of x. We have that for the absolute value. Another point we have on there is the point 1, 1. And in our parent graph, what I'll talk about a lot of times is as I go horizontally 1 step, I'm going vertical 1 step. Okay, so when I go to my transformed function, what I'm going to do is go to that point that we slid around here, translated from the origin, and I'll go and take 1 step out to the right. I like to go to the left first, and then go up that 1 step. And if I do that and I fall on my graph, what that tells me is there's no shrink and there's no stretch. Okay. Now the second piece will come in. If I do have a stretch and shrink, how am I going to know if it's horizontal or vertical? And when we looked at graphing, we noticed a lot of times that the vertical stretch and the horizontal shrink were the same thing. Okay, the vertical shrink and the horizontal stretch were the same thing. So with this section, when you're writing your equations, deal with them as a vertical stretch or a shrink, okay, not as a horizontal. So when we look at the same idea here, okay, when I took my parent graph, I went 1 in the horizontal, 1 in the vertical to get to my next point. Now if I try and do that here, if I go 1 horizontally and I go 1 vertically, my second point should be right there. And this is like the x-axis on my parent graph. And so because my real point is above where it should be, what I have there is a stretch. I've pulled it away from my axes. All you really need to look at is if I went 1 step to the right, how many steps am I taking up? And because I took 2 steps up, that means I'm stretching it by a factor of 2. Okay. Now, just like when we graphed, You can always check these things by typing the function that you just came up with into your calculator and looking at, does it appear to be the same? And again, you can use that trace feature just to punch in a couple points and make sure they match up. All right, so if we go through one start to finish, number one, parent graph, parabola, x squared. X squared, we still start at the origin. How did I translate to get my origin there? Well, what I did, I took 2 steps to the left, 4 steps down. The 2 steps left again is a horizontal translation, therefore it's inside, and again opposite, don't forget your square. The 4 is down, it's a vertical translation, so it goes on the outside. All right, now my stretch and shrink. What I'm going to do again is I'm going to take 1 step out. Okay, normally with my parent graph we took 1 step up. And so now what you can look at again is that I didn't get all the way to where I'm supposed to be. This is a situation where what I have is a shrink. But what I really want to look at again is when I took that 1 step out to the right, how far did I go up? And it appears to be about a half. And so my final function here then is 1/2, because it was a vertical shrink, the quantity x plus 2 all squared minus 4. All right, nice quick short little lesson for you. And only 8 problems on that worksheet, so hopefully to help you out.